This is stage one of the implementation next stop recommendation system under the project guide Dr. Maiga Chang and for the MyTags Global Link Internship 2021. So the stage one of the project basically comprises of 6 tasks, and each task is for a certain aspect in mobile app development. And let's look at it one by one. Okay, so the first task in stage one. Okay, so the 3 stages are, we have the mobile app development as the first stage, and where the mobile app is going to be created. And stage two is where we make the mobile app perform or work even when there's no internet connectivity. And the third stage is where the app is going to get the algorithm from the server. The server is going to be implementing an algorithm for the recommendation system, and there'll be two algorithms that will be implemented. One is for the point of interest, another is for the category, and we're going to get recommendations through the stage three's algorithm. So the first is the device registration. So device registration is pretty simple. We're going to make a signature on the device, and we're going to send it to the server. The server is also going to store the signature, and the server is going to send a user ID. It's a UUID, which is again stored both on the device and the server. And now, whenever we try to, we basically use the signature to make a CRC check every time whenever you're trying to send a request. So this is how we can validate a request if it's coming from a very particular phone, or if someone is trying to spoof it and someone is just trying to like put fake data into the database. All those things can be easily prevented using CRC checks. So you see that the device is registered successfully, and you can also go check. You can see the features of the app, and you can go check the database where the UUID and signature is getting stored. And the second thing it does is, once the device is registered, you're going to get something called OSM request. It's going to send an OSM request to the server, and the server is going to check if the location data for that particular location is already available in the server. If it's available, it's going to send it back. If it's not, it's going to download it from the OpenStreetMap server, and it's going to convert that into a database form, SQLite database form, and it's going to send it back to the device. So here you see that OSM request is also being sent to the server. And now here in this stage, we are just trying to like, in stage two, a cron daemon task is actually going to do this automated. Now I'm just trying to do it manually. I'm just trying to pass it as a request. I'm downloading the OSM on the database, and I'm trying to convert it into a data OSM file on the from the OpenStreetMaps, and I'm trying to convert it into a database. Now when I open the app, when the user is opening the app after that, you can see that the point of interest will be downloaded. Yes. And note that this will not be shown to the user. This is just for demonstration purpose. We just want to show that point of interest is being downloaded. And no such file is being downloaded. It's basically trying to import it into its local database. It's not downloading any file on the device. It's just trying to import it to its local database. So that was about that. And yeah. Now I'm demonstrating one more aspect of the task. So the location data is already available in the server, and if a user is requesting for the OSM data, you can see that it's directly downloading because the location data is already available. So that's another aspect of the task. Now about the stage two. Stage two is about recording point of interest and category. So whenever so there's two aspects again for this. One is the users clicked on checked run in background service. So basically, the location is being fetched every periodically automatically, and it's going to see if that's a matching point of interest in its local database, or whenever the user opens, it's going to run the service anyways, and the service is actually going to check if the current user's location is matching any point of interest in the database. So that's what's happening here. Now I'm using fake GPS to point my phone's location to a restaurant called MTR. And when I open the app, it's actually showing the MTR, Marvel Different Rooms, as a restaurant. It's coming. This is actually detecting a point of interest, and it's actually showing it on our history tab. And that was about that. And if you click on the point of interest, you can actually see the location on the OpenStreetMap. So the OpenStreetMap is actually showing you the restaurant there. And then if the threshold is reached, so for every category there's a threshold state time. If the threshold state time is reached, you will be actually storing that onto the server. So the server also will hold all the history of point of interest visited by every user. So that's why you have a UUID column, the name, the category, and the timestamp they visited. All these are stored in the POI history tab, POI history table, and that's how it's shown. Now, I'm just actually showing you that it's the same point of interest. So I'm getting the SHA value of restaurant, and you can see that the 32AC is the same as that 32AC in the category. So it's hashed and stored. So the administrator will not get to know what point of interest or what category the user has listed. He basically has no information. He has basically you just can see a sequence of hash values which doesn't make any sense, but the algorithm will take care of everything, and that's how that works. Now about the task free state status detection. Like I told you that every category can have a threshold state time, there should be a way to actually update or change values of each category. So that's why a portal is made for that purpose. So you can see that you can download, it says that you can download an updated CSV file here, and you can modify the threshold state time and again upload it below. So when you click on the file to be downloaded, uh, you can use that to modify it. So I'm storing the category CSV on the desktop, and you can see that for every category the threshold state time is there, and we'll be using that to change. For now we'll be changing the category state time of the category bar to 15 or 150. And now I'm also changing another category. Okay, so the first three categories are changed now. Now I'm uploading the same CSV file. Yep, so it's been imported. Now when you check, there's a category point of interest category table in the SQL database where the state time is changed and a 30-bit is set to 1, which means that the phones can use the 30-bit to actually update that information into the phone. And that's how the 30-bit is set to 1 and state time is 150. So the first three state times are changed. So you can see the 30-bit is set to 1 for these three things. And you can also see the Android Studio. Yeah. So you can see that I'm trying to log all the categories along with their threshold state, and you can see that the bars categories 150, BBQs is 60, and Big Gardens is 85. And yeah, those are the updated ones, and those are actually reflected in the phone as well. Now for the historical POI management task, which is the task 4 of the stage 1. Here we are just trying to like delete the point of, we should be able to delete the point of interest. We should be excluding, you should basically be excluding that point of interest from the recommendation algorithm, or you should click on it and you should be able to see it on the map. So the two things can be done. So if you click on it, you can you can see that location on the map. And if you long press on it, you should be able to exclude it. There's an option to exclude it. That's what's shown here. If you click on exclude, you will have an option to say, do you want to just exclude this point of interest, or do you want to exclude all the point of interest of this name, but visited in different timestamps? So if you say just this one or all, it's going to do as whatever is requested. Now, if you see that the point of interest is also deleted from the server, and then now again when I now I'm trying to show you the integrity check. So for the integrity check, what integrity check does is, if I am trying to do some operation without internet connectivity, and when internet is back again, I need to have the database in the local phone and database in the server to be consistent. If there's no internet connection, you will know that something will be added to the local device or something is deleted from the local device, which is inconsistent with the things on the server. So there's a integrity check implemented where of whenever the internet connection is back, is going to check the local server and it's going to check the server's database. It's going to see what has to be added, what has to be deleted, and it's going to do it as follows. So that's how I'm trying to delete it without internet connectivity. I'm deleting a point of interest, and you can see that the point of interest is not deleted on the server. Next time when I try to get back the internet connection by turning on the Wi-Fi. Now when I open the app back, and if you refresh the server's database, you should be able to see that that file is deleted. So that was about task 4 and task 5. Yeah, and finally the integrity check also has to be checked for another aspect where point of interest is added when the device is offline. So the device is offline, you visited a place, that place is actually added to the point of interest. Now I'm trying to mimic the same aspect. I'm offline, I'm visiting the hospital, Abaya hospital, and when I open, you can see that the point of interest is added. It's not Abaya Hospital, it's a point of interest near Abaya Hospital which has been recorded. And you can see that the point of interest is not added into the server. And now when I turn on the internet connection, you should be able to see it reflecting on the server. Now when the internet connection is on, the integrity check happens, and that's how the local server and the server database is not in sync, and it's in sync back in after the integrity check is done. Finally, get next stop recommendation. So basically, whenever user clicks on recommend next stop, they should have a loading screen to show that yes, the database is being processed and the server is trying to fetch the next recommendation personalized to the user. There should be a loading screen, and the loading screen is basically a bunch of graph nodes getting connected, and which signifies that it's trying to compute something and get you the next recommendation. So that's the point for the getting recommendations part. This was the task 6 for the stage 1 implementation. All these six tasks was about the stage 1, which was mainly focusing on the mobile app development. Here we're not looking into the service creation, or we're not looking into recommendation algorithms, which will be looked upon in the further stages. Thank you.